Hi everyone, welcome to the channel. Today we will be continuing with lecture 2 for the LEED Green Associate exam focusing on energy and atmosphere chapter. Without any further delay, let's move on to our presentation. If you haven't subscribed to my channel yet, please do so. Well, in the previous lecture, we have covered one prerequisite, that is fundamental commissioning and verification, and its connected credit, that is enhanced commission. Those who want to know more about that can check the previous video. And today's lecture, we will cover the next one prerequisite and its connected credit. So we will be covering minimum energy performance prerequisite and its connected credit, which is optimized energy performance, which holds the highest scores in this category, that is 18. Well, the intent of this prerequisite is to reduce the environmental and economic harms of excessive energy use by achieving a minimum level of energy efficiency for the building and its systems. Now we can talk about the requirements for achieving this prerequisite. So option 1 is all building energy simulation. The term simulation will be very familiar for the environmental design students, especially they have to work on numerous projects that require simulations. Well, simulation involves working with a large amount of data to provide an output, typically using a specialized software. It is actually modeling. So some of the examples of simulation tools, softwares include NVMet, Design Builder, etc. I won't go in depth on these simulation tools for now. We will continue with option 1. So for achieving option 1, we need to demonstrate the below table minimum energy performance improvement in the proposed building performance rating compared with the baseline building performance rating calculated according to ANSI ASHRAE IESNE standard 90.1 2010. It is very important with a narrative using a matrix of energy cost, source energy or greenhouse gas emission. These are the input we have to provide for the simulation. Or it can be a USGBC approved equivalent standard for projects outside the US. So let's look on to the table. The minimum energy performance improvement must achieve for new construction, major renovation, school, warehouse and distribution centers, hospitality is 10%, and for commercial and data centers it should be 8%, and for the healthcare it is 5%. As I mentioned, simulations work with a lot of data. When we input the standard data, we get a baseline. This baseline helps us to understand the current performance, and we can then make improvements or alteration to achieve our targeted performance. This is how it works. And this process is straightforward with simulation software, making it very easy to manage. Well, in simulation, we often work with two modeling. One is baseline things, as I mentioned in the previous slide. Another is proposed one. For the proposed one, we might do multiple options for that and pick one among them, the better one. So here, the proposed design meets certain criteria. Criteria number 1, compliance with the mandatory provisions of ANSI ASHRAE IESNE standard 90.1 2010, or it can be a USGBC approved equivalent standard for projects outside US. Number 2, inclusion of all energy consumption and costs within and associated with the building projects. And finally, comparison against a baseline building that complies with standard 90.1 2010 Appendix G, or it can be a USGBC approved equivalent standard for projects outside the US. So the credit associated with this prerequisite is optimized energy performance with 20 points, In the initial pages, I mentioned that 18 points for this credit. It was a small error because there was an updation happened in 2024. That's why its points changed. So the intent is to achieve increasing level of energy performance beyond the prerequisite standard to reduce environmental and economic harm associated with the excessive energy use. The requirements are same as the prerequisite. Here also it's all building energy simulation. We have to demonstrate that a minimum energy performance improvement is achieved for the proposed building performance rating compared with the baseline building performance rating calculated according to ANSI ASHRAE IESNA standard 90.1 2010 using a metric of energy cost or source energy or greenhouse gas emission, and for a USGBC approved equivalent standards for projects outside US using a simulation model, but the values varies. This table is showing the points for percentage improvement in energy performance beyond ASHRAE 90.1 2010. Here the points are awarded based on the percentage of improvement in energy performance. So for achieving as a prerequisite for new construction, major renovation, warehouse and distribution center and hospitality, 10% improvement in energy performance is required, and for schools is also it's 10%, and commercial data centers it's 8%, and for healthcare it is 5%. But additional improvements, the points also will increase till 10, and for 100% improvement in energy performance it is noted as exemplary performance. So this is how this table works. Well, the previous slide there is some small addition, and that table is showing actually the percentage of improvement in energy performance for cost or source energy. And here this table showing the 0.4% improvement in greenhouse gas emission beyond ASHRAE 90.1 2010. Here also the table works like the previous one. For achieving as prerequisite 10% of improvement in greenhouse gas emission is required. For school also it is 10, and commercial it is 8, and healthcare it is 5%, and for additional increment they also awarded point accordingly, and for 100% improvement it is noted as exemplary performance. I hope you understood every concept clearly. If you have any questions, please leave a comment below. And that's the end of today's lecture. If you haven't subscribed to my channel yet, please do so. Tomorrow we will start a new lecture. Until then, bye.